Welcome. This is the fourth and final page of the Chapter R review. I know that it is not from Chapter R, but we need to go over it because it is important nonetheless. We've got a quadratic over a quadratic, and we need to analyze it, make a graph. This is our function graphing stuff. This is a rational function, so I know it's going to have that look of a rational function that looks something like this, with some asymptotes and all this stuff going on. There might be holes, there might be vertical or horizontal asymptotes. Let's start to look at it. First thing I notice, the degree, they're both to the second power, which means that there is a horizontal asymptote, not at 0, but at the term on the numerator over the term on the denominator. So, this has got a horizontal asymptote at y equals 2 over 1, which is 2. With that, let's start factoring this thing. So, let's say 2 times, if I factor out a 2 in the numerator, x squared minus 6x plus 5, all of that's over x squared minus 8x plus 15. I'll factor those quadratics and have 2 times x minus 5, x minus 1, all over x minus 5, x minus 3. Okay, this tells us a lot more about our function than what we had when it was in standard form. For example, the x minus 5s will cancel out. What this tells us, when x is equal to 5, there is going to be a hole. It's going to be at 5 comma something. And we'll have to figure out what that something is, but we'll get there in a second. I also notice this x minus 1 in the numerator. This x minus 1 tells us that there is a 0 when x is equal to 1. So let's put in 1 comma 0 as our x-intercept. Finally, this x minus 3. This tells us that there is a vertical asymptote. It didn't cancel, so it's big drama. That's going to be a vertical asymptote at x equals 3. X equals 3 because it's a vertical line, y equals 2 for that horizontal line. So the y-intercept, that actually is something that we do actually get from standard form, because the y-intercept happens when x is equal to 0. And when x is equal to 0, everything cancels out except for that 10 over 15. So my y-intercept will be at 0 comma 10 over 15, which is 2/3. Last but not least, the hole. Let's go back to what that was. Now, when I canceled out this x minus 5, I end up with an equation that's 2 times x minus 1 over x minus 3. If I plug in 5 for my first equation, what I end up with is something that doesn't really work, because I'll have 0 in the numerator and 0 in the denominator. Luckily, the second equation, aside from that hole, looks exactly the same. So I can plug in 5 in here and see what I get. Well, that will be 2 times 4 over 5 minus 3 is 2, which gets me 4. So my hole is at, whoops, not 5 comma 4. What it comes down to now is graphing. So, there's the x-intercept is at 1, 0, so I will put a point at 1, 0. The y-intercept, that's at 0, 2/3, so I will put a point at 0 comma 2/3. The hole is at 5, 4, so I will go over 5, up 4. The asymptote is at y equals 2. Oh wait, that hole is not a point, but the absence of a point. Over 5, up 4 is a hole. Horizontal asymptote, no, vertical asymptote at y equals, horizontal, sorry, asymptote at y equals 2 will be drawn in here. vertical asymptote at x equals 3 is drawn up here. And now it's a matter of filling in the dots. Since I have so many points already, I can probably just sketch it in. I know that it's going to look something like this. And since I have to go through those dots, the 0, the y-intercept, and the whole as well, my rational function will probably look like this. If this is something that you still struggle with, definitely come in and see me. Definitely come to AM support. I want to make sure you get this, and so let's figure this all out. I hope you found this helpful. This is the final picture you get. Have a great day, and Chapter 1 review is coming soon.